So essentially what it states is, whenever you have two given polynomials where the larger polynomial, the polynomial with a greater degree is divided by a linear polynomial, how do you obtain the remainder? That is what the remainder theorem is. For example, Px is equal to x square plus 3x plus 6, for example, and Gx is 2x plus 3. Okay, so the question is, what will be the remainder when Px is divided by Gx? So we use remainder theorem here. Remainder theorem is when it is divided by a linear polynomial x minus a, the remainder is Pa, and when it is divided by x plus a, the remainder is P of minus a. How do we obtain that in practical cases? We have to equate Gx to 0. So 2x plus 3 is equal to 0, therefore x will be minus 3 by 2. This is what you do here. This is the remainder theorem. When you equate it to 0, x is a. Here when you equate it to 0, x is minus a. So the remainder in this case will be Pa, that is the value of x, and here it will be P of minus a, that is the value of x when you equate Gx to 0. So similarly in this case also we equated Gx to 0. The value of x that we got was minus 3 by 2. Therefore the remainder when Gx is divided by when Px is divided by Gx will be P of minus 3 by 2, which will be equal to minus 3 by 2 whole square plus 3 into minus 3 by 2 plus 6. So you get 9 by 4 minus 9 by 2 plus 6. You take 4 as the LCM, you have 9 minus 18 plus 24. What do you get? 6 and 15 by 4. So the remainder will be 15 by 4. This is solving a question to find out the remainder by using remainder theorem. Note that in case of using the remainder theorem, what we are doing is we are using the linear polynomials. Linear polynomials only. Here it is a linear polynomial. We take a linear polynomial, equate it to 0, get the remainder, we substitute it here in the value of P in Px, and whatever the value is going to be the remainder. This is the remainder theorem. And how we obtained it, there was a proof that we just did before this, and we used the result dividend is equal to divisor into quotient plus remainder. We extended it to polynomials, and then we figured out this remainder theorem. So this is what the remainder theorem is. From this only the factor theorem is derived. What is a factor theorem? Stating the factor theorem, we have So the factor theorem states that if x minus a is a factor of Px, then Pa equal to 0, and if Pa equal to 0, then x minus a will be a factor of Px. This x minus a can be resubstituted as x plus a. It basically means it is basically true for all linear polynomials, but we have given it a general form. So whenever x minus a is a factor of Px, then Pa is equal to 0, and if Pa equal to 0, then x minus a will be a factor of Px. This factor theorem is actually an extension of the remainder theorem that you know. What does the remainder theorem state? Remainder theorem would state when x minus a divides Px, you get a remainder Rx, which is actually equal to Pa. This was the remainder theorem. Now let's take this example of 35 being divided by 7. You get a remainder 0. So when the remainder becomes 0, then what can we say? We can say that 7 is a factor of 35. Similarly, when Pa equal to 0, we can say that x minus a is a factor of Px. Pa equal to 0, then x minus a will be a factor of Px. And the other way around as well. If x minus a is a factor, that is, if we know that this is a factor of this, so x minus a is a factor of Px, then obviously the remainder is going to be 0. So this is what the factor theorem states. Remainder theorem was a more generic thing where you found out that the remainder was PA. The factor theorem would clearly say that PA would be 0 if x minus a is a factor of Px, or if PA is 0 then x minus a would be a factor of Px. How do we use this in questions is a very important aspect, and this we are going to take up next. Let us take these two basic examples. The first one says if Px is given as 4x cubed minus 3x squared plus 2x minus 4, find the remainder when it is divided by x plus 2. For this we will be using the remainder theorem, and remainder theorem says that when Px is divided by Gx, equal to x plus a, then the remainder will be P of minus a. How do we get that? We simply take the Gx, we equate it to 0, whatever the value of x is, we will have to find the P of that value, and this is going to be the remainder. So here the remainder will be, for the question 1, remainder will be P of minus 2. How did we get minus 2? We equated the Gx to 0, and whatever the value of x is, we take it as a. So remainder will be P of minus 2, which is equal to minus 2 cube minus 3 minus 2 square plus 2 into minus 2 minus 4 is equal to minus 8 minus 32. This will be 4 into 3, 12, minus 4 minus 4. So you have minus 8 minus 20 of minus 52 here. So the remainder is going to be minus 52. So this is the first question. The second question asks, is 7 plus 3x a factor of 3x cubed plus 7x? Since we have to find out the factor, we have to use the factor theorem. What does the factor theorem state? X plus a will be a factor of Px if P of minus a equal to 0. If x plus a is a factor of Px, then P of minus a is equal to 0. This is the factor theorem. So here we will have to equate 7 plus 3x to 0. So we have equal to 0. So we have x equal to minus 7 by 3. And to check whether it is a factor of Px, we have to check P of minus 7 by 3. P of minus 7 by 3 would be 3 into minus 7 by 3 whole cube plus 7 into minus 7 by 3. This is not equal to 0. Hence 7 plus 3x is not a factor of Px from the factor theorem. So this is how you use the factor and the remainder theorem. Let's take a few more critical problems related to this.